Permutations and combinations. We need to first start with the factorial notation. By definition, for a natural number, that means whole positive number, we can define n exclamation mark, which is n factorial, means n times n minus 1, n minus 2, up to 1. And by definition, 0 factorial would be 1. For example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And we can type all of that in calculator and we should get 120. Then 3 factorial would be starting from 3 times 2 times 1. So this is equal to 6. Then 7 factorial means that we go 7 times 6 times 5 times 4 times 3 times 2 times 1. We can also write it down, so this we can type it on a calculator, and this would be 5040. We can also, now on calculator, we should have the factorial button. That's either, it should be something like second function, either you have a button n factorial, or you can have a button just factorial, or you can have a button x factorial. So if you type 7 and then factorial, that should give you right away this one. Most often it's second function for the factorial. Now we can use, and this is gonna be more convenient, that for example, if I have 7 factorial, I can write that this would be 7 times 6, and this I can write as factorial. So the 7 factorial, we can write 7 times 6 times 5 factorial. 5 factorial means that you're going down, 5 going down. Also, that 7 factorial, we could have written that this 7 factorial could be 7 times 6 factorial, because 6 factorial means that we're going down up to 1. So whole this part would be 6 factorial times 7. We will use them if we need to cancel. Instead of writing all the numbers out, we can simply write 6 factorial. That means you're going down up to 1. So n factorial can be some number times 1 less, but the factorial on the way. Example 1. Evaluate, and we have first example. So for part A, we have 7 factorial divided by 9 factorial. So we're gonna rewrite the bigger number, so 9. We can write that 9 would be 9 factorial would be 9 times 8 times, and 7, and we can keep going, 7, 6, and so on. So instead of going down, we would write 7 factorial, because on the top we had 7 factorial, and whole the 7 factorial can cancel out. So what I am left is 1 over 9 times 8, which is 1 over 72. Part B, we have 5 factorial divided 0 factorial, 3 factorial. So choose the bigger number, which is 5, and keep going down until we get some smaller number. So 5 times 4 times 3, and we could go 3 to 1 or keep it 3 factorial, over 0 factorial by definition is 1. And then we had 3 factorial on the bottom. We had the 3 factorial here. So then we can cancel 3 factorial, and we are left only with 5 times 4, which is 20. Part C. We had 3 factorial times 4 factorial over 6 factorial. This is equal. I like to start with the bigger factorial until I get to some number. What is there? So we have 6 times 5 times 4 and can go down 4, 3, 2, 1 or 4 factorial. On the top, I will keep this 4 factorial because I want to cancel later on. But then the 3 factorial, we can work it out. 3, 2, and 1, right? So we have 3 times 2 times 1. And everywhere is multiplication, so we can cancel 4 factorial. And also 3 times 2 is 6, can be cancelled with 6 on the bottom, whole 6 divided by 6. And what I am left with is only 1 over 5. Part D, we have 15 factorial divided by 13 factorial. So this is equal to 15 times 14 times 13, and we can keep going or write 13 factorial over 13 factorial was on the bottom. Then 13 factorial cancel out, and I am left with only 15 times 14, and that gives me 210. Permutation. In permutation, order is important, and I will explain this on an example. So the number of permutation of n things r at a time is given by p and r, which is n factorial, n minus r factorial. Now, if we have p n r n at a time, then n things n at a time, we have n factorial choices, because by the definition would be n factorial over n minus n is 0 factorial. 0 factorial is 1. So we are left with only n factorial. Now, if we have permutation n 0 at a time, we have only one choice for that. N things 0 at a time. So let's evaluate, find p permutation 8 things 4 at a time. So this is equal to, by the definition, would be the number first 8. So it's 8 factorial divided by, and then we have n minus r, so we subtract those two, so 8 minus 4 factorial. 8 minus 4 factorial. And this is equal to, so we have 8 factorial over 8 minus 4 is 4 factorial. And as we did in the first example, this is gonna be equal to 8 times 7 times 6 times 5 times 4, and keep going to the bottom, or 4 factorial over 4 factorial. 4 factorial cancel out, and if we type the left on the calculator, we should get 1680 choices for part A. For part B, exactly the same. We would have 6 factorial divided by 6 minus 2 factorial. So what we're doing, according to the formula, always first on the top, and then you subtract those two. So 6 on the top, and then 6 minus 4 factorial. So this is equal to 6 factorial divided by 6 minus 4, 6 minus 2 is 4 factorial. So this is equal to 6 times 5 times 4 factorial divided by 4 factorial. So that gives me 4 and 4 factorial cancel out. So that gives me 6 times 5. So this is equal to 30. There is 30 permutations. Now, you should be able to type this on your calculator. Very likely you have a second function choice. Some calculator has N, P, R button. In that case, you would type 8, press that button NPR, and then you type 4. And if you type equal sign, you should get the number what we have right here. You should get this number. So that should give us 1680, this one on calculator. So some calculator has this button, some calculator has this button, exactly like P, N, comma, R. So choose any button. Very likely is second function, it's on the top. Look for that button and try to get that numbers. The same on this one. If you have this NPR button for permutation, in this case we would basically type it 6, press this one, and then 2, and you should get the answer as 30. Now, I said order is important. Here is example Y. How many 4-digit numbers can be formed using those digits? So in that case, this order is important because if I have 1, 2, 3, 4, that's one number. And then if I have 4, 3, 2, 1, this, you see, the order in which I put those numbers is important. So that means we using, because that gives us different numbers. If this is distinguished, give us different numbers, that means order matters. So that means we're choosing the permutation. In that case, we're gonna have permutations. How many numbers we have? We have 9 numbers. And we're choosing how many? 4-digit. So we're choosing 4. So we have permutation 9 and 4. So this by definition would be 9 factorial over 9 minus 4 factorial. So that gives me 9 factorial over 5 factorial. And if we want to work it out, this would be 9 times 8 times 7 times 6 times 5 factorial all over 5 factorial. 5 factorial cancel out, and the rest we can type on calculator, and we should get 3024 choices. Also try using the permutation button on your calculator, that you type it 9 permutation button 4, and you should get this number. In how many ways, example 4, in how many ways can a librarian arrange 6 books on a shelf? So this order also is important. In what order? Because you have different arrangement. So in that case, we're gonna have permutation 6 choose 6. 6 choose 6 would be 6 factorial over 6 minus 6 factorial. So this is 6 factorial over 0 factorial. 0 factorial is 1 over 1. So this, we simply have 6 factorial. So this is equal to 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial, and we have 720. Example 5. How many 3-letter codes can be made using letters from the word festival? So 3-letter codes, if you switch the order of the code, that you have a different code. That's why order is important. So if order is important, we're using permutation. So we're gonna have permutation. How many letters to choose from? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, and we have permutation of 3. So we have 8, take 3 at a time. So if we want to solve it manually, it would be 8 factorial over 8 minus 3 factorial. So this is 8 factorial over 5 factorial. So this is 8 times 7 times 6 times 5 factorial, or divided by 5 factorial. 5 factorial can cancel out, and what we are left with, multiply this out, and we're getting 336. Now we have combinations. In combinations, order does not matter. I will explain this in 1 second. The number of combinations of n distinct objects taken r at a time is given by C for combination is n factorial over r factorial over n minus r factorial. Combination n choose n. If you have an object you choosing n, you have pretty much one choice. But if you would like to do it according to this, so it's n factorial over the bottom factorial, and then you subtract those two. And if you have n choose 0, you have only one arrangement because as they were standing at the beginning. So now we have example 1, combination 5 choose 3. So by the definition, this would be 5 factorial over 3 factorial over 5 minus 3 factorial. So we have the first number on the top, second number on the bottom, and then we subtract them for the second one. So this is equal to 5 factorial over 3 factorial times 2 factorial. So this is 5 times 4 times 3 factorial over 3 factorial times 2 times 1. 3 factorial can cancel out. Also 4 and 2 reduces to 2. So what I am left with is 5 times 2. So the answer should be 10. For part B, the same. We're gonna have 12 factorial over 10 factorial over 12 minus 10 and factorial. That gives me 12 factorial over 10 factorial times 2 factorial. So this is 12 times 11 times 10 factorial over 10 factorial times 2 times 1. So this one I expanded right here. I'm gonna cancel the 10 factorial, so I left it. 2 factorial is 2 times 1. And then we can reduce it. So 10 factorial cancel out, and then 2 and 12 reduces to 6. So we have nothing else but 6 times 11, which is 66 choices. Also practice with the calculator. On calculator, you can have it N, choose R button, and if you have this button, or you can have it C and R. Some calculator have like this, some calculator has like this. If you have the first one, you could type it that this would be 5, press this NCR button, and then press 3 and equal, and you should get the same answer. Or you can do it with the N with a different button as well too. Very likely a second function button. Now, example, in how many ways can you select a committee of 3 students from 10 people? So you see the 3 students that we're selecting, that's the same committee. So in that case, the order does not matter. That's what we said here. Order does not matter. For combination, order does not matter because I can have student 1, student 2, and student 3. And if I switch them, student 3, student 2, student 1, that's still the same committee. So you see, if I change the order of them, it's not making different combination. So for combination, if order does not matter, that would be the case. Because if you're using code or a number, that's a different number. But if you put people together, that's the same, still the same committee. So that means the order does not matter. So in that case, how many ways can we select a committee of 3 students from 10 people? So that would be combination. We have 10 people, we're choosing 3. By definition, this is 10 factorial over 3 factorial over 10 minus 3 factorial. This gives me 10 factorial over 3 factorial times 7 factorial. Work this out. So we have 10 times 9 times 8 times 7 factorial over this 3 we would expand, this we would leave it because we want to cancel with this one. So we have 3 times 2 times 1 times 7 factorial. Reduce what you can reduce. So then 3 and 9 can be reduced to 3. And then 2 and 8 can be reduced to 4. So then if we multiply, what we are left with is 10 times 3 times 4. So that gives me 120 choices. Example 8. How many ways can you select a committee of 3 girls and 2 boys if there are 15 girls and 10 boys? 10 boys in a class. So we're gonna select 3 girls from girls and 2 boys from boys. So since the order is not important, so we're gonna use combination. So we have combination, girls, 15 girls, we're gonna choose 3. That would give me the 3 girls, and then I'm gonna choose 2 boys from 10 boys. Choose 10 from 10 boys, choose 2. And we will multiply the choices because we need both together. And the rest we can either type it or multiply and get this one. So this would be 15 factorial over 3 factorial over 15 minus 3 factorial. And this gives me 15 factorial over 3 factorial times 12 factorial. Then we're gonna do the rest. So this is 15 times 14 times 13 times 12 factorial over 3 times 2 times 1 times 12 factorial. This 12 cancel out. 3 and 15 reduces to 5. 2 and 14 reduces to 7. So this part should give us 400. This part gives us 455. And then we're gonna multiply, and then we do the same. 10 factorial over 2 factorial over 10 minus 2 factorial. So this is 10 factorial over 2 factorial times 8 factorial. So this is 10 times 9 times 8 factorial over 2 times 1 times 8 factorial. 8 cancel out. 10 and 2 reduces to 5. So now we have 45. And if we multiply this times what we have, I'm getting 20,000. I'm getting 20,475 choices. Example 9. A bucket contains 8 green, 6 blue balls. In how many ways 3 balls can be selected if 2 balls are green? So we're choosing 2 greens from green and 1 from blue. So for part A, we're choosing green balls, so 8 choose 2 greens and 6 choose 1. So we have 8 factorial over 2 factorial over 8 minus 2 is 6 factorial. This would be 6 factorial over 1 factorial over 6 minus 1 is 5 factorial. So this is 8 times 7 times 6 factorial over 2 factorial times 6 factorial times, and this would be 6 times 5 factorial over 1 times 5 factorial. We cancel out what we can. This factorial we should have write 2 times 1. So then 8 and 2 reduces to 4. And here this cancel out. And if we multiply everything all together, we have 28 times 6. So this gives me 168 choices for part A. For part B, we need 3 blue balls. So we're choosing from blue balls. There are 6 blue, so we have 6, choose 3. So this would be 6 factorial over 3 factorial, and then we have 6 minus 3 gives me 3 factorial. So this is 6 times 5 times 4 times 3 factorial over 3 times 2 times 1 times 3 factorial. One of those factorials I expanded. Second factorial I'm keeping as is because I would like to cancel. So then this cancel out. 3 times 2 is 6. So the 6 and 6 reduces. So this total number of choices is just 20.